Please note that this AI-generated podcast is intended solely for general learning and educational purposes. While we strive to ensure accuracy, the AI may occasionally produce errors or incomplete information. We strongly encourage you to consult qualified professionals and conduct your own due diligence before making any legal, financial, or business decisions based on the content presented here. Also, any views and opinions expressed in this podcast are those of the podcast creator alone and do not reflect or represent the views, positions, or policies of any organization, institution, or entity, past, present, or future, with which the creator is or may be affiliated.
The scope of patentable innovation is fundamentally defined by the requirement of non-obviousness under 35 U.S.C. Section 103. This ensures that patents are reserved for true innovations, not for trivial or predictable extensions of existing technology. The critical standard we use is the PHOSITA, the person having ordinary skill in the art. This is a hypothetical person who possesses ordinary creativity and technical knowledge in the relevant field, but is explicitly not an innovator or genius. If the differences between the prior art and the claimed invention would have been obvious to the PHOSITA, the scope of patentability is exceeded. To determine this objectively, we apply the four-part Graham factors. First, we establish the scope and content of the prior art. Second, we identify the differences between that art and the claimed invention. Third, we determine the level of ordinary skill in the art, setting the PHOSITA benchmark. Fourth, we must consider secondary indicia, such as commercial success or unexpected results. The key limitation on the scope of innovation today is predictability. As established by case law, combining familiar elements is obvious when it yields no more than predictable results. For instance, the mere aggregation of known features that perform no new function together is not patentable. However, if a combination yields a result that is unexpectedly superior, that result pushes the invention back within the scope of patentable non-obviousness.
Welcome to the Deep Dive. Today, we're tackling something absolutely central to innovation and intellectual property, the standard that separates a truly patentable invention from just a clever improvement.
That's right. We're zeroing in on the non-obviousness requirement. If you're trying to understand what makes an invention really count in the eyes of the law, this is it.
We're going deep into 35 U.S.C. Section 103. This is the section of U.S. patent law that lays it all out. It's often the biggest hurdle for inventors.
Absolutely. It's the gatekeeper. Your invention might be totally new, never seen before, solves a huge problem. But if it's deemed obvious under this statute, well, no patent for you. The public gets it right away.
And that's the crucial point, isn't it? People get novelty. If it's already out there, you can't patent it. Simple enough. But non-obviousness, that's trickier.
Much trickier.
Yeah, because lots of things are new but still unpatentable. Why? Because they were sort of the next logical step. Something a skilled person in that field would likely have come up with anyway.
Exactly. And the purpose behind this is really important for how technology progresses. Patents are meant to reward a genuine inventive leap, something surprising, something non-predictable.
Right.
If the improvement was, easily figured out based on what was already known, the law says we can't let one person monopolize that. That kind of predictable progress needs to stay open for everyone to use and build upon.
Okay, so the big question then becomes, how do you measure obvious? Because what seems obvious to a rocket scientist is totally different from what seems obvious to me or to a baker. It feels subjective. How does the legal system make this objective?
That's the million-dollar question, and the law's answer is pretty clever, actually. It created a hypothetical benchmark. To get that objectivity, the entire analysis hinges on this concept. The PHOSITA, that stands for Person Having Ordinary Skill in the Art.
PHOSITA. Okay, This isn't a real person.
Nope, purely hypothetical, a legal construct, but a really important one. Think of the PHOSITA as the objective yardstick against which we measure the invention.
So this hypothetical person is the gatekeeper. They decide if the inventor made a real leap or just connected the dots in a predictable way. What are they like? What skills do they have?
Well, first off, they possess ordinary skill and knowledge in the specific technical field of the invention. And ordinary is key.
Not extraordinary.
Not extraordinary. Not a genius, not a leading innovator, not someone with a Nobel Prize. Just competent, solidly skilled for that particular field.
And that skill level changes depending on the field.
Absolutely. If we're talking about, say, advanced gene editing, the PHOSITA is probably someone with a PhD in molecular biology and years of lab experience. If it's a new kind of garden tool, maybe a mechanical engineer, or even an experienced tradesperson, the standard adapts.
Okay, so the skill level matches the text complexity, but what about their mindset? You said they're not an innovator.
Right, that's critical. The PHOSITA knows everything publicly available in their field up to the date the invention was effectively filed, all the patents, articles, existing products, you name it. They have perfect knowledge of the prior art.
Wow, perfect knowledge. Okay.
And they're capable of routine experimentation. They can apply known techniques, combine existing elements in predictable ways, and achieve expected results. If combining component A with component B is standard practice to get a predictable outcome, the PHOSITA would do it.
But they lack the spark, the out-of-the-box thinking.
Exactly. They don't make inventive leaps. They won't try something that goes against the established wisdom in the field. They won't invent a whole new way to combine things if the old ways don't work. They follow the predictable path.
So like the ultimate engineering follower. Diligent, knows everything, but won't blaze a new trail.
That's a good way to put it. They're the objective filter used to fight hindsight bias. After something's invented, it often looks easy in retrospect.
Oh yeah, why didn't I think of that?
Precisely. The PHOSITA forces us to step back to the time before the invention existed, look only at what was known then, and ask, based only on that knowledge, would this hypothetical ordinary skilled person have found the solution obvious?
Okay, and defining this PHOSITA, their skill level, what they knew, that must be a big deal in actual patent disputes.
Huge. It's often one of the first battlegrounds. The patent owner wants to define the PHOSITA as having lower skill, making the invention seem more brilliant. The challenger wants to define them as highly skilled, making the invention look like just another day at the office for them. Getting that definition right sets the stage for the whole obviousness argument.
All right, so we have our hypothetical PHOSITA, but we can't just ask them, hey, was this obvious? We need a structured way to guide their judgment, right? To keep it grounded in facts.
Exactly. And that structure comes from a really seminal Supreme Court case, Graham versus John Deere Company back in 1966. Before Graham, determining obviousness could be a bit fuzzy, more based on a judge's gut feeling sometimes. Graham changed that. It laid down a mandatory 4-part factual analysis that has to be done every single time. These are known as the Graham factors.
Okay, let's break them down. Factor 1.
Factor 1 is determining the scope and content of the prior art. This is where we build the library of knowledge that our PHOSITA has access to. We need to figure out precisely what information, what patents, what publications, what existing products were publicly known before the inventor's critical date, usually the filing date.
So everything relevant that was out there, what counts as out there?
It's broad. Patents from anywhere in the world, published articles, textbooks, technical manuals, products that were sold or used publicly, even presentations at conferences sometimes. It's a global search for relevant knowledge.
And relevant is key, I guess. The PHOSITA working on a new drug probably doesn't care about advances in airplane wing design unless there's some weird connection.
Generally, yes. The prior art needs to be reasonably pertinent to the problem the inventor was trying to solve, or from a field that someone skilled in the art would logically turn to for solutions. So, you define that universe of knowledge first.
Okay, that's the foundation. What's Graham Factor 2?
Factor 2 is identifying the differences between the claimed invention and the prior art. Once you know what existed, you have to pinpoint exactly what the inventor added or changed. You compare the specific claims of the patent, the legally defined invention, against the closest things you found in the prior art search.
So, getting really precise. Like, the prior art showed steps 1 and 2, and the invention claims steps 1, 2, and 3. The difference is step 3.
Precisely that level of detail. You need to clearly articulate what's new. If there are no differences, well then it's not novel, let alone non-obvious. But usually there's some difference, even if small.
Got it. On to Factor 3.
Factor 3 brings our friend the PHOSITA back explicitly, determining the level of ordinary skill in the pertinent art. This is where we nail down that skill level we talked about earlier. How educated, how experienced. What kinds of problems do people in this field normally solve?
And this connects back to the differences found in Factor 2.
Directly. We measure the significance of those differences against the capability of this ordinary skilled person. A small change might seem trivial to someone with deep expertise, but revolutionary to someone less skilled.
How do courts actually figure out this level of ordinary skill? Is it just guesswork?
No, it's based on evidence. Things like the educational level of people working in the field, the complexity of the technology, the types of problems encountered, the solutions that were already known. Often, expert witnesses will testify about what a typical person in that field would know and be able to do.
Okay, so 1, what was known? 2, what's different? 3, who's the judge? The PHOSITA. What's the 4th factor?
Factor 4 is crucial, especially when the first 3 factors don't give a clear answer. These are the secondary considerations, or sometimes called objective indicia of non-obviousness.
Objective indicia. Sounds important.
They really are. These are real-world factors that can provide strong evidence that the invention wasn't obvious. They act like clues from the marketplace or the technical community, suggesting the invention was a genuine breakthrough.
Okay, like what kind of clues?
Probably the most common one is commercial success. If the product based on the invention becomes a huge seller, the argument is, if it was so obvious, Why didn't someone else make this successful product first?
Makes sense. What else?
Evidence of a long-felt but unsolved need. If people in the industry were struggling with a particular problem for years, trying and failing to find a solution, and then this invention comes along and solves it, that strongly suggests the solution wasn't obvious.
Right, because skilled people were already trying.
Exactly. Which leads to the related factor, failure of others. If competitors, maybe even big companies with lots of resources, tried to solve the same problem and gave up, that's powerful evidence that the path wasn't obvious.
Okay. Any others?
Yes, unexpected results is a big one. If the invention works much better than anyone would have predicted based on the prior art, or achieve something in a surprising way, that points away from obviousness. We'll see this with the Adams case later. And finally, sometimes evidence of copying by competitors can be relevant. If others chose to copy the invention rather than designing around it or coming up with their own solution, it suggests they recognize something uniquely valuable and non-obvious about it.
These secondary factors sound pretty persuasive. But you mentioned a caveat earlier, something about Apple versus Samsung.
Ah, yes, a very important point. You can't just point to massive sales of a complex product like an iPhone and say, see, commercial success. My patented antenna inside must be non-obvious.
Why not?
Because the courts require a nexus, a direct link, between the commercial success or the long-felt need, etc., and the specific features claimed in the patent. Maybe the iPhone sold well because of brilliant marketing, or the App Store, or the overall design things unrelated to that specific antenna patent.
So the success has to be because of the invention itself.
Precisely. You have to show the market valued the patented feature. So the Graham factors give us this structured, fact-based framework, looking at the art, the differences, the skill level, and these real-world indicators, all before making that final call on obviousness. Now, a huge chunk of inventions, maybe most inventions today, aren't completely new things pulled out of thin air. They're combinations of elements that were already known.
Right, like taking technology A and merging it with technology B.
Exactly. And this is where non-obviousness gets really interesting and, frankly, challenging. The law has to figure out, when is combining known things truly inventive and when is it just, putting two things together predictably? Mere aggregation versus true synergy.
Okay, so let's look at some examples. You mentioned a case that shows real synergy, United States versus Adams, from 1966, same year as Graham.
Yes, Adams is a classic. It involved a battery, specifically a non-rechargeable water-activated battery. The inventor, Adams, combined two known materials, a magnesium electrode and a cuprous chloride electrolyte.
Both known components. So what was the issue?
The issue was that the existing knowledge, the prior art, actually taught against using that specific combination, especially in a water-activated battery. The experts at the time believed that combination would be inefficient, short-lived, maybe even dangerous.
Wow, so the PHOSITA wouldn't have just been unmotivated to combine them. They would have thought it was a bad idea.
Precisely. That's called teaching away, and it's incredibly strong evidence of non-obviousness. If the experts are saying don't do this, and you do it and it works surprisingly well,
then you've likely made a non-obvious leap. So what happened with Adams' battery?
it worked remarkably well. It produced a strong, stable current, lasted a long time, and defied all the negative predictions. It had unexpectedly superior results.
A synergistic effect. The whole was greater than the sum of the parts' predicted abilities.
Exactly. The Supreme Court said that even though the elements were old, the combination was non-obvious because it produced this unexpected superior result that flew in the face of conventional wisdom. It wasn't just adding functions, it was creating a new, better function through a surprising interaction.
Okay, Adams is the gold standard for non-obvious combinations. What about the other side? When is it just sticking things together? You mentioned Anderson's Blackrock versus Pavement Comey from 1969.
Right. Anderson's Blackrock is sort of the anti-Adams. This case involved road paving. The invention was combining a known radiant heat burner, which was used to heat the edge of existing asphalt, with a standard paving machine that lays down new asphalt.
How were they combined?
They mounted the burner on the front of the paving machine. So as the machine moved forward, the burner heated the pavement edge right before the new asphalt was laid, making for a better bond.
That sounds useful. Efficient, maybe.
It probably was useful and efficient. But the Supreme Court said it was obvious. Why? Because the combination performed no new or different function.
Explain that.
The burner still just heated, like it always did. The paver still just paved, like it always did. Putting them together on one machine made the process more convenient, but it didn't change how either component worked or create some unexpected interaction between them.
So it was just aggregation,
Right.
like duct taping a flashlight to a hammer. Both still work the same way, just together now.
Exactly. It was predictable convenience. The PHOSITA, knowing about burners and pavers and how to mount things on vehicles, would have seen this combination as a straightforward, predictable way to improve efficiency. There was no synergy, no surprise.
Was there a similar case about efficiency not being enough? Socrata?
Yes, Socrata versus AG Pro Inc. in 1976. This one involved a system for cleaning dairy barns. It combined several known elements: a system for flushing the barn floor with water, sloped floors, and drains to carry the waste away.
Again, sounds like a practical setup.
It was. It definitely made cleaning barns faster and easier, more efficient. But the Supreme Court found it obvious.
Even though it was a better system, why wasn't that enough?
Because, again, each element just performed its known function in a predictable way. Water flushed, gravity made it flow down the slope, the drain collected it. The court basically said this was just arranging old elements using basic mechanical principles to get a predictable, more efficient result.
So the takeaway from Socrata and Anderson's BlackRock is that just making something more efficient or convenient by combining known parts isn't enough if the way they work together is totally predictable to the PHOSITA.
That's the key point. You need that element of unpredictability, that unexpected result or synergy, like in atoms, to really make a combination invention stand out as non-obvious. Efficiency alone, if achieved through predictable means, usually won't cut it.
Okay, so we have Graham setting the framework, and these early cases like Adams and Anderson's BlackRock illustrating the difference between synergistic combinations and mere aggregation. How did the standard evolve after that?
Well, for quite a while, especially in the specialized patent court, the Federal Circuit, a very specific test for combination inventions became dominant. It was called the Teaching Suggestion Motivation Test, or TSM test.
TSM, okay, what did that involve?
The idea behind TSM was to make the obviousness analysis more objective and less reliant on sort of gut feelings. It basically required that for a combination of known elements A and B to be found obvious, there had to be some explicit evidence in the prior art. A patent, an article, something written down that specifically taught, suggested, or motivated a person of ordinary skill to combine A and B.
So you literally had to find something saying, hey, you should combine A and B.
Pretty much, or something very close to it. If you couldn't find that explicit pointer in the prior art, the invention was often found non-obvious under the TSM test, even if combining A and B seemed like common sense.
That sounds really rigid, like it might miss obvious combinations if nobody happened to write down the suggestion.
It was rigid, and that became a big criticism. It sometimes led to patents being upheld for inventions that seemed, well, pretty obvious to people working in the field, just because that specific suggestion wasn't documented anywhere. This rigidity really came to a head in a major Supreme Court case in 2007, KSR International Co. versus Teleflex Inc.
KSR. Okay, this sounds important. What was the invention there?
KSR involved a patent on an adjustable gas pedal assembly for a car, combined with an electronic sensor to detect the pedal's position. Both adjustable pedals and electronic pedal sensors were known in the auto industry.
So a combination of known elements again. And Teleflex, the patent owner, argued it was non-obvious because...
Because, using the TSM test, there was no single prior art reference that explicitly said, combine this specific type of adjustable pedal with this specific type of electronic sensor.
But the Supreme Court didn't buy it.
Not at all. The Supreme Court unanimously rejected the rigid application of the TSM test. They said it was too narrow, too formalistic. It failed to capture the role of common sense, ordinary creativity, and marketplace realities in the obviousness analysis.
So what did KSR say instead? What's the modern approach?
KSR brought back a more flexible, holistic approach, emphasizing predictability and common sense. The key principle from KSR is essentially, if you combine familiar elements using known methods and the result is predictable, that combination is likely obvious.
Even without an explicit suggestion in the prior art.
Yes. The court said the PHOSITA isn't an automaton who only acts on explicit instructions. They have common sense. They understand market trends. They know that certain problems have known solutions.
How did that apply to the gas pedal?
The court noted that the auto industry was rapidly moving towards electronic sensors for everything. It was a known trend. Making pedals adjustable was also common to accommodate different drivers. So combining these two known features, adding a standard electronic sensor to an adjustable pedal, was seen as a predictable design choice driven by market demands and ordinary engineering problem solving, not an inventive leap.
So KSR basically said, look, you have to consider the real world, common sense, and predictability. It wasn't just about finding that one magic prior art document.
Exactly. It broadened the inquiry significantly. KSR explicitly mentioned other ways a combination could be obvious, like when there are only a finite number of known predictable solutions to a problem, making it obvious to try each one, or when a design choice is simply driven by market pressures or obvious improvements. It put common sense back into the PHOSITA's toolkit.
That sounds like a big shift, making it potentially harder to patent combinations that might have passed the old TSM test.
It definitely raised the bar for combination inventions, requiring more justification beyond just the lack of an explicit suggestion in the prior art.
How did this KSR flexibility play out in fields that aren't mechanical, like biotech, where results can seem less predictable?
That's a great question. The principles of KSR were quickly applied across all fields, including complex ones like biotechnology. A key case here is Inricubin from 2009.
Kubin, what was that about?
Kubin involved trying to patent a specific DNA sequence that coded for a known protein. The inventors used established, standard lab techniques, basically, known methods to find and isolate this DNA sequence, starting from the known protein.
Okay, known starting point, known methods. Sounds like it might be predictable.
That's what the court thought. The inventors argued it wasn't obvious because finding the exact sequence wasn't guaranteed beforehand. But the court, applying the KSR logic, focused on whether the PHOSITA here, a skilled molecular biologist, would have had a reasonable expectation of success using those standard methods.
A reasonable expectation of success, not absolute certainty.
Right. The court said if the path forward using known techniques was clear and success was reasonably likely, even if not 100% guaranteed, then discovering the expected result, like isolating that DNA sequence, could still be obvious. Just running a known playbook, even in a complex field, isn't enough for non-obviousness post-KSR.
So KSR and cases like Kubin mean the modern PHOSITA is expected to be pretty savvy, aware of trends, capable of applying known techniques logically, and possessing good old common sense.
That's a very good summary. The focus is less on finding explicit instructions and more on whether the claimed invention would have been predictable or obvious to try for that ordinarily skilled person, using their common sense and the available tools.
Okay, this evolution from the strict Graham factors through the rigid TSM test and now to the flexible common sense KSR standard. It must have really changed how inventors and companies approach patents.
Oh, absolutely. The practical implications are huge, both for people trying to get patents and for those trying to challenge them.
Let's talk strategy. If you're an inventor or applicant and you get a rejection from the patent office saying your invention is obvious under Section 103, especially after KSR, what's your best line of defense?
Your strongest arguments usually come back to demonstrating unpredictability. You need to show why the FOSA wouldn't have expected your result or wouldn't have taken the path you took.
So leaning heavily on those secondary considerations from Graham.
Exactly. You need hard evidence of unexpected results. Show data proving your invention works significantly better or differently than predicted. Even better is proof of teaching away, showing that the prior art actually discouraged the approach you took, like in the Adams battery case. That directly counters the idea that it was common sense. Evidence of long-felt need or failure of others also helps paint the picture that the solution wasn't just lying there waiting to be picked up.
So focus on the surprise factor. What about the other side? If you're a company being sued for infringing a patent, how do you use obviousness as a defense?
If you're the defendant challenging the patent's validity, KSR is your best friend. Your whole goal is to paint the patented invention as nothing more than a predictable combination of known elements.
How do you do that?
You scour the prior art to find all the building blocks. Then you argue that putting them together was just a matter of common sense, routine engineering, or maybe it was obvious to try because there were only a few known ways to solve the problem. You emphasize market trends that push towards that solution. Essentially, you argue the PHOSITA would have inevitably arrived at the same invention without any real inventive spark.
It sounds like the battle often comes down to, was this a surprising leap or a predictable step?
That's often the core of the dispute.
Let's try to make this even more concrete with some everyday examples. Forget the case law for a second. How would the PHOSITA view some common types of innovations? Let's stick with tech and maybe medicine.
Okay, think about cameras. An obvious example today might be adding improved electronic image stabilization software to a new model of smartphone camera.
Why obvious?
Because image stabilization is a well-known feature, constantly being improved incrementally. Integrating a known type of software improvement into a standard device like a smartphone camera to get a predictably better result, smoother video, is likely something the PHOSITA in optical or software engineering would expect. It's a common market demand, a known technique applied to a known device for a predictable benefit.
Right. Almost expected in a new phone release. Now give me a non-obvious camera example.
Okay, how about this? Inventing a completely new type of camera sensor based on, say, quantum dots that allows a tiny camera to capture detailed thermal images and visible light images simultaneously with high fidelity using a single lens system, something previously thought impossible without complex, separate systems.
Oh, okay. Why is that non-obvious?
Because it represents a fundamental shift in capability, likely based on discovering new material properties or a novel sensor architecture. The PHOSITA, based on existing sensor tech, wouldn't have predicted that such integration and performance were possible in that form factor. It provides an unexpected result, dual-mode imaging with high quality from a single, simple system solving problems of complexity and size in a surprising way.
That makes sense. The first is an expected upgrade. The second is a surprising new capability. What about in medicine or pharma? Combination drugs are common.
Right. An obvious example there could be combining two well-known over-the-counter pain relievers, like ibuprofen and acetaminophen, into a single pill for general pain relief.
Why obvious? People do that all the time, taking both separately.
Exactly. The combined effect is generally understood to be additive. You get the pain relief from both, working through their known separate mechanisms. There's usually no surprising interaction. The PHOSITA, a pharmacologist or a physician, would predict the outcome based on the known properties of each drug. It's mostly about convenience.
Okay, predictable additive effect. What's a non-obvious drug combination?
A non-obvious example would be combining two known drugs, maybe drug X originally for blood pressure and drug Y originally for arthritis, and discovering that together they have a potent and synergistic effect in treating Alzheimer's disease, an effect far greater than the sum of their individual effects and completely unexpected based on their known mechanisms.
Synergistic and unexpected. 2 + 2 = 10 kind of thing.
Precisely. That synergy, that surprising new therapeutic benefit targeting a different disease, strongly suggests a non-obvious discovery about how these drugs interact at a biological level. The PHOSITA wouldn't have predicted this specific outcome based on the prior art related to blood pressure and arthritis. That's potentially a huge inventive lead.
So really, if we boil it all down, the whole process, Graham factors, KSR, PHOSITA, is trying to answer a series of questions to get at that core idea of surprise.
That's a good way to put it. You start with the facts. What's the scope and content of prior art? What do we know? Then, what are the differences? What's new? Who's judging? The skill level of PHOSITA. What does the real world say? Secondary considerations. Then, critically, post-KSR. Was the result predictable using common sense and known methods? And finally, does the invention offer genuinely unexpected results or synergy? It's a funnel toward assessing that inventive spark. #TechOutOutro.
So when you step back, 35 U.S.C. Section 103, this non-obviousness requirement, is really acting as this critical filter. It's trying to make sure that the powerful reward of a patent monopoly goes to those inventions that genuinely push technology forward in a surprising way.
That's right. It prevents people from locking up the small, predictable improvements that naturally flow from existing knowledge. Those need to remain free for everyone to use, allowing technology to advance cumulatively.
And the standard itself isn't static. We've seen how it's moved from those early cases through the rigid TSM test phase and landed on this more flexible, common sense, predictability-focused approach guided by Graham and especially KSR.
It's a constant balancing act, incentivizing big leaps while not stifling the everyday progress that relies on combining and refining what we already know. It's inherently fact-specific now, looking at the whole picture.
It really is. Which brings us to a final thought for you, our listener, to maybe ponder. Given that the benchmark, the PHOSITA, the person of ordinary skill, is constantly learning, constantly adapting as technology races forward.
Their ordinary skill level is always rising.
Exactly. So think about the cutting edge today. AI creating art, CRISPR editing genes, new quantum computing breakthroughs. What seems utterly groundbreaking, almost magical to us now, might seem like a completely obvious, almost trivial application of standard techniques to a PHOSITA just 20 years in the future.
What's non-obvious today could easily be obvious tomorrow.
That ever-shifting line is the fundamental ongoing challenge for inventors, for patent attorneys, for the whole system trying to define what truly counts as an invention worth protecting. It's a fascinating problem.
It certainly keeps things interesting. The goalposts are always moving.
Thank you for joining us for this deep dive into patent non-obviousness.
Thanks for tuning in to the full episode. If there's any topic or case law you'd like us to cover next, Share your suggestion in the comments on our latest video. And if you found value in the podcast, don't forget to like, subscribe, and hit the bell icon to stay updated.